Alright guys, so yesterday we named with stuff that was only in the S block. We did a lot of sodium and potassium and magnesium, and we kind of ignored the transition metals, and we only used aluminum was the only metal from the P block that we used. And that is because the rule that we learned yesterday only applies to metals in the S block and certain transition metals, ones that have only one oxidation number. Oxidation number is the same thing as charge. So right down here we have a list of the elements that are transition metals that only have one charge. Nickel's always a +1, zinc is always a +2, silver's always a +1, cadmium's always a +2. It'd be a good idea to kind of keep those in the back of your mind. That will help you with naming later on. Most transition metals and metals that are in the P block have more than one oxidation number or more than one charge, and because of that we have to name them a different way. So see here on this chart we can see, for example, iron. Iron can be a +3 or a +2. When iron's +3 it's called iron 3, and the 3 is a little Roman numeral. When iron's +2 it's called iron 2, and the 2 is a Roman numeral. So those Roman numerals are what we are going to use to name the elements, the transition metals, and the atoms in the P block that can have more than one charge. And the Roman numeral is the charge of the ion. So since, like I just said, since the metal ion can have more than one charge, a Roman numeral is used to specify the charge. If I just named something gold chloride, well, gold can be a +1 or gold can be a +3. And if I just say gold chloride, it's not clear which charge the gold has. And there's two possible formulas then. We could have AuCl if gold was a +1, or we could have AuCl3 if gold was a +3. So you have to specify which ion of the transition metal you are using. And again, the charge the metal ion has is indicated by Roman numerals. So if I have iron 2 oxide, that means my iron is a +2 charge. Copper 1 chloride means my copper is a +1 charge. So that Roman numeral is not how many of the atom you have in the formula, it is the charge of the ion. Sometimes you have to work backwards to figure out the charge of the transition metals. Like we said, iron can be a +2 or a +3, and the way you know which charge you have is how it's bonded to the anion, how it's bonded to the negative ion. So this is FeS. And we know, if we look at our periodic table, sulfur is always a -2. 1,000,000% of the time, sulfur is a -2. So in order to get the neutral compound FeS, that means that iron had to be a +2. So our next one, copper and chlorine, we know that chlorine, we know that chlorine is a -1. So in order to balance out that -1 charge, copper has to be a +1. Now it gets a little bit more complicated when you have more than one of an atom. So for example, Hg, mercury, and oxygen. We know oxygen is a -2. And again, I'm just getting that by looking at the periodic table. Mercury is not a +2. I don't know what the charge of mercury is, so I'll call it X. But I know that my negative charge is 2, right? I have one oxygen with a -2 charge, so my total negative charge is 2. I don't know the charge of my mercury, we'll call it X. I know that I have 2 mercuries in this formula though, and I know my total positive charge has to be +2. So basically you're just asking yourself what times 2 makes 2, and the answer is 1. So the mercury is a +1 charge, the oxygen is a -2 charge. So again, this X is the charge. That X is the charge. And then the number next to it is how many you have of that atom. So we're going to do SnS2. That's tin and sulfur. We know sulfur is -2. So I'm going to take that charge, -2. I'm going to multiply it by how many sulfurs I have, and that will give me a total negative of 4. For the tin, I don't know the charge, but I know that I have 1 tin, and I know that my total positive charge has to be 4. So therefore, what times 1 makes 4? The answer is 4, so tin has a positive 4 charge. So now we're going to practice and we're going to name these compounds. In order to name them, you need to know the charges of the metal ions. So to find the charges of the metal ions, I'm going to do what I just did on the last slide. I'm going to use the anion. So for example, we're going to start with CuCl2 because that one's a little bit easier. I know chlorine is a -1 charge. So I'm going to take the charge, I'm going to multiply it by how many chlorines are in my compound, 2 of them, because there's a 2 right there. So I'm multiplying it by 2. And I get my total negative charge is 2. Now I need to figure out the charge of my copper. And I know, because all ionic compounds are neutral, I know in the end I need to get an end result. Oh, this isn't writing. Come on. Of positive 2. So I don't know the charge of my copper. We're going to call it X. But I know that I have 1 copper in the compound. And I know that my total positive charge at the end has to be positive 2. So basically it's a very simple algebra question. What times 1 makes 2? And the answer, hopefully, you got real easily, is 2. So that tells me that this compound is copper 2 chloride. Okay, so let's do the CO and the N, because that one again is a little bit simpler. I know it's going to be cobalt blank, and then because of the N, nitride, and then I have to fill in that blank, and I fill in that blank with the charge of the cobalt. So we work backwards from the charge of the nitrogen. Nitrogen is -3. I take that charge, I multiply it by how many nitrogens I have, that gives me my total negative charge is -3. So I know my total positive charge has to be positive 3. I don't know the charge of the cobalt, so we'll call it X. I have 1 cobalt in that compound. So what times 1 makes 3? The answer is 3. So it's cobalt 3 nitride. Alright, so now let's go back up and do the Fe2O31. So again, I know I'm going to in the end have iron blank oxide. And I fill in that blank with the charge of the iron. And I don't know if the charge of that iron is a +2 or a +3. I work backwards from the oxygen. So oxygen's a -2. I take that charge. I multiply it by how many oxygens I have. Gives me a total negative of 6. So I know my total positive has to be 6. I don't know the charge of the iron. So I'm going to take the charge, the charge of the iron, X, times how many irons I have. I have 2. And I know X times 2 has to be 6. So I know X equals 3. Hence this is iron 3 oxide. So again, when you're figuring these out, you guys, this number, hold on, let me make it red. This number is the charge. See, X, it's the charge. And then we'll do this one in black. This number is how many you have. So I have 3 oxygens, I have 2 irons. That's why I'm multiplying those. So now we're going to go the other way. We're going to take the name and we're going to write the formulas. And this is really exactly like what you were doing yesterday. If I have iron 3 iodide, the only thing that's different is this number right here, this Roman numeral, is the charge of my iron. That tells me my iron is a positive 3. Iodide, the ide tells you it's a monatomic. It's just the atom by itself. Iodine is a negative 1 charge. So just like what we were doing yesterday, they have to balance out. So you're going to need 3 iodines to balance the charge of the iron. Doing titanium 3 oxide, again, the 3 is the charge. So titanium with a plus 3 charge. Oxide tells me it's just oxygen with a negative 2. So my formula is going to be Ti2O3. Okay. Chromium 3 sulfate. Now 8 tells you polyatomic ion. So chromium with a plus 3. Sulfate with a minus 2. So it's going to be Cr2SO4 in parentheses with a 3 on the outside. Lastly, copper 1 chlorite. Remember, ite, polyatomic. Copper is a plus 1. Chlorite is ClO2, negative 1 charge, so it's CuClO2. So that is writing names and formulas that are a little bit harder for ionic compounds, but as long as you figure out the charge of the metal, it's not too bad. There is this flow chart here for you to kind of help you walk through what you do. Right now we're only working on this side of the flow chart. So we're going to start metal present, yes. All of them are yes. Does the metal form more than one cation? If no, you do what we did yesterday. If yes, you have to determine the charge and use a Roman numeral for the charge. So all of your homework will be this type using the Roman numerals. Tomorrow we'll go over how to tell when you do which, when you use a Roman numeral versus when you just write the name. All right, so make sure you study for your polyatomic ion quiz tomorrow and do your homework. We'll go over it in class. Have a great day.